Good day all, welcome to another learning support video. Throughout school, you were told that the first derivative gives us the gradient of the tangent, but you weren't really explained why this is the case. So this video is going to be on the start of calculus, first principles, and why it is able to give us the gradient of the tangent. And the first thing to look at is to look at the stock standard formula for gradient. And as you can see, gradient is defined as the change of y divided by the change of x. And first principles use this same concept. First, let's take the graph y equals x squared, for example. If we wanted to approximate a gradient between 2 points, we would just take 2 points and use the gradient formula as shown. But what if we needed to find the instantaneous gradient, or in other words, the exact gradient of a single point? And this is the birth of the first principle formula, which is denoted to us by the limit of change in x approaches 0, f of x plus change of x minus f of x over the change of x. And this equation is actually just a variation of the normal gradient formula. To see what I mean by this, let's take the equation y equals x squared. And since there is no other point to compare it on the graph, to find the gradient, let's make up an arbitrary point, y equals x plus change in x squared, which is basically the same point plus change in x units to the right, which will obviously give us a y value of x plus change of x squared. And as you can see, now we can use our normal gradient formula and take our new y value, x plus change in x squared, and subtract the original y value, x squared, and put it all over x plus change in x minus x, which was basically our x values from our 2 points. And as you can see, the bottom therefore simplifies to just change in x. So now you can see this is starting to look a lot like that first principle formula. The next thing to understand is that the smaller the change in x, the closer the value is to the instantaneous gradient. And it is for this reason that the limit of change in x approaches 0 is added to our equation, so that as the change of x gets closer to 0, the closer we get to the real gradient. And it is due to our limit laws we are able to actually get this instantaneous gradient. Thanks for watching another learning support video, guys. As always, please leave a like and subscribe on the video. And also, guys, please let me know in the comments if there's anything you would like me to explain next. Thanks a lot, guys. I will see you all on Friday. Thank you.